In the challenge for the last stage, you built a simple program to generate a random number. A user supplied two numbers, and your program generated a random number between the two. It worked fine if the user actually typed in numbers into the input fields, but the program didn't work if the input was something like the word 7, or if the input field was left blank. As a programmer, you'll often encounter times when your program has to react intelligently to input from a user. For the random number generator challenge, it would be a good idea to first check to see if the input supplied by the user is a number. If it is, then you can generate a random number. But if it's not a number, then you could print out a message like, "Please type a number." That's just one example. There are many times in programming where you'll need to make a program behave differently based on conditions within the program. For example, in a space shoot-'em-up game, if the player loses all of her ships, the game should end. Or if the player reaches 1,000 points, the game should get faster and more difficult. You can change how your program behaves by adding decision-making to it. Programmers can make a program react to different situations by using what are called conditional statements. A conditional statement can be as simple as, "If this is true, then do that." For example, if the user types a number, then generate a random number from 1 to the number the user supplied. Or in a space game, if the player is out of spaceships, then end the game. Let's create a simple example of a conditional statement by building a quiz. You can follow along in Workspaces if you'd like by clicking the Launch Workspace button. Open the quiz.js file. First, we'll ask a question and get a response from a user. Next, I'll add the basic structure for a conditional statement. Conditional statements begin with the if keyword. Just like when creating a new variable, you use the var keyword. After if comes a set of parentheses. Inside the parentheses will go the condition. The condition is just a simple test whose answer is either true or false. Then come a set of braces. Inside the braces, you put the code that runs only if the condition is true. The braces create what's called a code block that can hold one or more JavaScript statements. Notice that unlike most other statements you've learned so far, there is no semicolon after the last brace. Weird, but that's how it works. Just don't put a semicolon at the end of a conditional statement and you'll be okay. Let's fill this out a bit. This condition is a test. It asks if the value that's stored inside the variable named answer is equal to the string Ruby. In other words, did the user type the word Ruby into the input dialog box? The triple equal sign is called an equality operator, and it's used to test if two values are exactly the same. If they are the same, then the condition is true and the code inside the braces runs. To make the code easier to read, it's common practice to indent the code that goes inside the braces, just like it's common in HTML to indent nested tags. Indenting the code makes it easy to see that the code block belongs inside the conditional statement. In this case, if the person answers the question correctly, then "that's right" is written to the page. Let's try it out. I'll save this file and preview the workspace. Cool, that works. Let's see what happens if I don't type the correct answer. I'll just reload this page. Nothing happens at all. Okay, well, this is the first time in our programming where code we've added to a program doesn't always run. Conditional statements let you control the flow of a program, that is, which code runs and when. In this example, when the condition is true, the program follows one path and prints "that's right" to the web page. However, if the answer is wrong, then we skip the document.write method. In either case, after the conditional statement, the program continues and runs any code that follows. We can also provide code that runs only if the condition is false. This is called an else clause. It's optional, but is often used as a kind of fallback for when a condition isn't true. You add it to a conditional statement like this. The code you want to run if the condition is not true goes inside the pair of braces.
following the word else. Those braces form a second block of code, and there's no semicolon after them either. I indent the code here as well so I can see that it's part of the else clause. Let's see what this does. Now, there's a response if you type the correct answer, and one if you type the wrong answer. But you'll never see both messages at once. Only one message appears, and it's entirely dependent on what happens in the conditional statement. Let's look at the basic structure of a conditional statement that includes an else clause. In programming, we call this an if-else statement. The two sets of braces create two code blocks. You can think of them as two doors, door number 1 and door number 2. With an if-else statement, you can only ever go through one of the two doors, never both. The condition, the stuff inside the parentheses, determines which code the program will run. In other words, which door the program will enter. The condition always is either true or false. If it's true, then the program enters door number 1. If the condition is false, then it's door number 2. But it's only ever one of the doors, and only ever one code block that runs. Once the conditional statement is finished, the program continues. Before we move on to the next video, let's look at one problem with my quiz program. I'm going to preview my workspace again and try the quiz. This time I'll type Ruby in all lowercase letters. Look at what happened. The program thinks I answered the question wrong, and strictly speaking, I did. To computers, a lowercase r is not the same as an uppercase R, so Ruby in all lowercase letters isn't equal to Ruby with an uppercase R. Fortunately, we can get around that using a string method you learned about in the second stage of this course. The toUpperCase method takes a string and converts all of the letters to uppercase. We can apply that method to what the user typed like this. I also need to change the case of the string I'm testing to all uppercase too. Now, even if the user types in Ruby in all lowercase letters, the condition will pass because it'll be converted by the toUpperCase method to all uppercase letters, and that matches our string.
As you can see, conditional statements let you make a program behave differently depending upon circumstances within the program. The value a user types into a form or the score in a game, for example, can change how the program runs. Conditional statements make your programs flexible and more interesting. In the next video, we'll look more at how conditions work. In the last video, you learned about an important programming concept, the conditional statement. Programmers use conditional statements to control the flow of their programs and make them respond differently based on conditions inside the program. The most important part of the statement is the condition itself. It's a test that checks to see if something is either true or false. For example, in this code, the condition is spaceships equals 0, which breaks down to a simple question. Is the value stored in the variable spaceships equal to 0? The answer is either yes or no. If the answer is yes, the game is over and an alert dialog appears. As it turns out, all conditions, no matter how complex, end up with a simple yes or no answer. Or, as computers like to think of it, true and false. JavaScript provides lots of ways to test things. We've seen the triple equals operator, which is a way to test the equality of two things. You can use that operator to see if the value a user typed matches a particular string, or if the value in a variable is a particular number. JavaScript provides other comparison operators to help with conditional statements. The greater than and less than symbols are great for comparing numeric values. For example, you can make a game harder if the player's score is greater than 1,000. Or, on the other hand, if a visitor is less than 18 years old, you could tell him to come back when he's older. To get some practice understanding conditions, let's look at a few examples on the screen and you decide if the condition is true or false. 3 greater than 2. This is true because 3 is a larger number than 2. 100 greater than 100. This is false because the two values are the same. 100 isn't greater than itself. How about this? 100 greater than or equal to 100. This is true because although the value on the left isn't greater than the value on the right, it is equal to it. Negative 12 less than 0. This is true because negative numbers are smaller than positive numbers or 0. Okay, one more. Apple less than bear. The greater than and less than operators aren't limited to just numbers. In this case, the comparison is true because the first letter of the string on the left, the A in apple, comes before the first letter of the second string, the B in bear. That is, A comes before B in the alphabet. Letter strings will always come after number strings too. That is, if you compared a number and a number is less than a letter. JavaScript provides two ways to test if values are equal. The double equal sign is called the equality operator. It lets you test if two values are the same, but it makes some allowances for different types of values. For example, 3 inside of quotes is a string, and 3 without quotes is a number. But if you use the double equal sign, then the browser actually converts the string to a number before comparing them, like this. This comparison is true because the JavaScript interpreter converts the string to the number 3 and says that, yes, the number 3 is the same as the second number 3. The triple equal sign is called a strict equality operator. It compares the type as well as the value. In this case, the comparison is false because one value is a string and the other is a number. They aren't the same type of value, so they aren't equal. It might seem like using the double equals operator is better since it seems more flexible. However, professional JavaScript programmers tend to use the triple equals operator and avoid the double equals. Why? Because you can get into some weird situations when using just the double equals operator. Here's one example. This is true, huh? An empty string is equal to 0? But if you use the strict equality operator, the result is false, what you'd expect. In many cases, the two equality operators work the same, but there are a few cases, like the one I just showed you, where the double equal sign will get you into a lot of trouble. In this course, I'll be using the strict or triple equals operator. Let's look at a few examples using the strict equality operator. This comparison is false because the two numbers aren't equal. This one is also false because those strings have different letters in them. Whereas this one is true because those strings are the same. But remember that JavaScript is case sensitive. So this comparison is false because the first string has all lowercase letters and the second doesn't. A lowercase j isn't equal to an uppercase j. JavaScript also provides a way to test whether two values are not equal. There's the basic not equal operator. It's an exclamation mark followed by an equal sign. The exclamation point is called a not operator. So exclamation equals is not equal to. It's better to use the strict not equals. That's exclamation equals equals. For the same reasons, it's better to use the strict equality comparison operator. Let's look at a few examples of the strict not equals operator. This comparison is true because 10 isn't equal to 9. This is also true because the value on the left is a string and the value on the right is a number, so the two types don't match. This comparison is also true because the uppercase R in the first string isn't the same as the lowercase r in the second string. This comparison is false because the two numbers are the same.
Let's write a program that uses conditional statements. In this program, we'll create a random number and have the visitor try to guess that number. If you want to follow along in Workspaces, just click the Launch Workspace button and open the script.js file. First, we'll generate a random number between 1 and 6 and store it in a variable. This uses the basic formula you learned in the last stage for generating a random number. Next, we'll prompt the user for a response. Now we can test to see if the response matches the random number. I'll start by creating the framework for a conditional statement. This is an if-else statement. In other words, if the condition is true, then one set of code runs. If it's false, then the other set of code runs. I'll add the test condition. As you learned in the last stage of this course, the input from the prompt method is always a string, so we need to convert it to a number using parseInt, so that we can compare that number to the random number we created in the first line of this program. If the condition matches, then let's write a message letting the player know she's right. If the condition is false, then we'll tell them the correct number. Here I'm using string concatenation, combining several strings to get one longer final string. In this example, the number inside the random number variable is converted automatically into a string. You don't have to do that yourself. Let's see how it works. I'll save the file and preview the workspace. All right, I'm thinking of a number 5. Hey, I guessed the number. Let's see what happens now. I'll try 2. Oh, wrong. The number was 4. Oh well, I got it right the first time. In the next video, we'll look at a new value type in JavaScript called the Boolean.
A condition in a conditional statement is really just a question with a yes or no answer. In JavaScript, we say that the condition evaluates to either true or false. True and false have specific meaning in JavaScript. They're called Booleans, and along with strings and numbers, they represent a third type of value in JavaScript. Though they have an unusual name, Booleans are very simple. In fact, a Boolean value can be only one of two possible values, true or false. That's it.
Let's look at Boolean values in action. You don't need to follow along in Workspaces for this. I'm just going to use Workspace to demonstrate these concepts. You'll be doing plenty of programming in just a minute. In JavaScript programming, the two possible Boolean values are represented by the keywords true and false. Because all conditions return a true or false value, we can actually see how these two keywords work by using them in this code. If I type true inside the condition and preview it, the condition is true is printed to the screen. Now, if I type false inside the condition and preview it, the condition is false is printed to the screen. Notice that there are no quote marks around true or false. They aren't strings. They each represent a specific type of value, a Boolean value, so don't put quotes around them. You can assign a Boolean value to a variable, just like you can assign a string or number to a variable. This is a common way to keep track of a certain condition throughout a program. For example, let's see how we can use a Boolean value in the random number guessing game. You can follow along in Workspaces by opening the workspace on this page. Open the script.js file. Here's the program you created in the last video. First, I'll add a new variable named correctGuess and set it to the Boolean value false. When the game begins, the player hasn't yet guessed anything, so we'll say the guess is false. The value of this variable will only change if the player gets the correct answer. So, next I'll remove the else clause here and change the correct condition code block to set the variable to true. So, if the player guesses the correct number, the correct guess variable changes to true. If the player guesses wrong, the variable isn't changed. It stays what it was set at the beginning to false. We can then test that variable and print out a message that matches the condition. This is a lot of code, I know, but this is a second conditional statement that we've added to the quiz. We now have two conditional statements. The second one checks to see if the value in the correct guess variable is true. If it is, then it writes a message telling the player he was correct. If not, then a different message is printed telling the player what the random number was. You can simplify this code a bit. Remember that all conditions are either true or false. That is, the test condition produces a Boolean value. Because we're already storing either true or false in the correct guess variable, We don't need to use the equality operator at all. We can get rid of it and just leave the Boolean variable there. Let's step through this code line by line. First, we create a variable with the Boolean false value. Next, we create a random number. We open a dialog box and ask the user to supply a number. Then, the program tests the user's response. If the user supplied the same number as the random number, then the correct guess variable is changed to true, meaning the player correctly guessed the answer. If the player didn't, however, then the variable stays the same, false. Then we have a new conditional statement. If the value in correct guess is true, then we write a winning message. However, if the value is false, then we'll tell the player the number. Let's see it in action. Now, you might be wondering, why did we go to all this bother? The program worked just fine before adding this new variable. Well, first it gave us a chance to start using Boolean values in our program. But more importantly, it's going to make the program more flexible, and it'll let us respond to multiple conditional outcomes. This is something you'll learn about in the next video.
So far, the conditional statements we've created provide just two possible paths, door number 1 or door number 2. If the condition is true, like the visitor guessed the correct random number, then the program goes through door number 1. But if the condition is false, then the program goes through door number 2. Hey, but what if you want many different outcomes, not just two? In our daily lives, we're used to many possible outcomes. For example, say it's your day off from work and you're trying to figure out what to do for the day. Your first step might be able to find out what the weather's like. Based on this, you could plan your day. For example, if it's hot and sunny, you might go swimming. If it's snowing, you might go sledding or skiing. And if it's raining, you might stay in and read a book. You can't do all three, only one. And each choice is based on a series of conditions. JavaScript also includes a way for a program to provide multiple outcomes, using what's called an else-if clause. It works like this. You start with a simple conditional statement, then add an else-if clause, which provides another condition to test. Now you have two conditions. If the first one is true, then the code in the first block between the first pair of braces runs. Let's call this door number 1. However, if the first condition is false, then a second condition is tested. If the answer to that condition is true, then the code in the second code block runs. Let's call this door number 2. The second condition is not tested if the first condition is true. This is important. You'll only get to the second condition if the first is false. Now, if neither of the conditions is true, you might want to provide a fallback, door number 3, so that the program does something. You can do this by adding an else clause to the end. There is no condition for this last part. However, the code block at the end only ever runs if both of the conditions above are false. There's no limit to the number of else-if clauses you can add. However, you must start with an if clause, and the else clause, if there is one, must go at the end. Now there's 4 test conditions and 5 possible outcomes, but only one will ever run. And keep in mind that as soon as one test condition is true, the code for that condition runs, and all the conditions following and the last else clause are skipped.
Let's put the else-if clause to use in the random number guessing game that we've been working on in this stage. At this point in the game, the player either guesses the correct answer or not. But we can improve it by giving the player a clue, then letting the player guess again. Let's see what the finished project will look like. When the player fills out the prompt dialog box, there are 3 possible outcomes. If the guess is equal to the random number, then the player wins and the program's over. But if the guess isn't correct, then we'll check to see if the guess is less than the random number. Then we'll tell the player that the random number is larger. In other words, we'll give him a clue and let the player guess again. If the player's second guess is correct, then the player wins. Otherwise, the player loses. However, if the original guess is more than the random number, then we'll tell the player that the random number is smaller than their guess, and we'll let them guess again. Now, if the player's second guess is correct, the player wins. Otherwise, the player loses. You can follow along in Workspaces by clicking the Launch Workspace button on this page. We need to perform 3 tests. First, does the player's guess match the random number? If not, is the player's guess less than the random number? If not, is the player's guess greater than the random number? I'll start by adding two else-if clauses. Then I'll add conditions to each. First, is the guess lower than the random number? Next, is the guess higher than the random number? Okay, let's deal with this first else if. If the guess is lower, we'll let the player know and guess again. Now we have a new guess from the player, provided by a second prompt dialog. We need to test to see if the second guess is correct. We can do this by nesting a conditional statement inside our code block. Here's a good example of why indenting your code is important. This new conditional only runs if the else-if clause here is true. That is, if the player's guess is less than the random number. This condition tests to see if the second guess is correct, and if it is, it sets the correct guess variable to true because the player got it right. Now we just need to repeat this for the case when the player's guess is greater than the random number. We can leave the rest of the program the same. Notice that if the player is correct, we simply change the value of the correct guess variable to true, indicating that the player got the answer right. That's done here, here, and here. Then, in this last if-else statement, at the end of the program, we simply test the value of this variable and print the appropriate message, if the value is true or false. I'll save the file and preview the workspace. Now I have a second chance to guess if my first guess is wrong. That's a lot of code. In fact, this is the longest program we've written so far. In the next video, you'll learn how to add comments to programs to make it easier to understand how a program works.
It's a lot of fun to program, but it's not always fun to return to a program you wrote 6 months or a year ago. Looking at an old program sometimes feels like you're reading a foreign language. It's easy to forget why you programmed something the way you did. Fortunately, JavaScript provides a way to leave messages in your code that can help explain what's happening in a program. When you look at your code later, you can read these messages, or comments, and quickly understand what's going on in your program. You can add comments anywhere in your JavaScript code. They're ignored by a web browser and don't affect how your program works. Where should you put comments? Well, it's a good idea to add comments to identify different sections of code. For example, to introduce a long conditional statement, or to explain particularly complex blocks of code. Comments are useful not just for you, but for anyone else who might need to work with the code you've written. JavaScript provides two different types of comments. Single-line comments are represented by two forward slashes. Everything following those slashes until the end of the line are ignored by the browser. If you want to add a long message to your code, you can use a multiple-line comment, which begins with a forward slash and an asterisk. Anything following those two characters, even carriage returns and multiple lines, are ignored until the browser encounters a final asterisk and forward slash. I'll show you how to use comments by documenting our random number guessing game. You can follow along by opening the workspace on this page. Just click the Launch Workspace button. First, I'll add a multi-line comment that just explains what the program does. It's common to add a multi-line comment like this to the beginning of a JavaScript file. This is a place where many programmers put copyright notices, contact information, and other bits of data about the program. Now I'll add a single-line comment. I like to put the comment directly before the code I'm commenting on. In this case, I'm explaining what the next line of programming does. I'll add another comment. Now, you don't need to comment every single line of your code. For example,
This next line is pretty obvious. It opens a prompt dialog and stores the user's input into a variable. Now, you might add a comment that explains a bunch of code that follows. For example, the next part of this program is our first conditional statement. You could add a multi-line comment here to explain what it does. That comment explains all of this code. So I'll add just one last comment to explain the last part of our program, the final conditional statement. Adding comments to your programs is very helpful for you and anyone else who needs to see your code in the future. Get into the habit of using them.
Sometimes a single condition isn't enough to make a decision. For example, even if it's a hot day, you don't want to go swimming if you don't know how to swim. In this case, you might ask, if it's a hot day and I know how to swim, then I'll go swimming. There's actually two tests here. Is it a hot day? And do I know how to swim? But they both have to be true in order to move on to the action, going swimming. If the first condition is false, for example, it's not a hot day, then no action is taken. If the second condition is false, I don't know how to swim, it doesn't matter if it's a hot day, I won't be going swimming. In JavaScript, we have a special operator for this type of test. It's called an AND operator and is represented by two ampersands. You place one condition on either side of the two ampersands. The two conditions are evaluated separately, but work together to create a single Boolean value, true or false. For example, say you wanted to test if a variable held a number between 20 and 30. There's no single comparison operator you can use to see if a number lies within a certain range. However, you can use the AND operator for this. Let's assume that we have a variable named age. You could test the value in this variable like this. What we really have here are two separate conditions. 20 is less than age, and age less than 30. Each condition is tested separately and produces its own true or false values. Let's try this out. Imagine that the value in the age variable is 25. The first test asks if 20 is less than age. In other words, is 20 less than 25? Yes, it is, so that first condition is true. The second test asks if age is less than 30. So, is 25 less than 30? Yes, it is, so that condition is also true. Then, the AND operator steps in and combines the two. It asks, is condition 1 true? And is condition 2 true? In this case, yes, they're both true, so the result is a true value. Let's continue with a few other examples. Let's assume that the value in age is 35. The first condition is true. 20 is less than 35. But the second condition, is 35 less than 30, is false. So the entire condition is false. How about we set the value of age to 10? The first condition is false, but the second condition is true. That doesn't matter because just one is false. The entire condition is false. Finally, let's say there's a string value in the variable. Well, that isn't a number at all, so it can't be compared to a number. In this case, both tests are false. And logically enough, the entire condition turns out to be false. As you can see, the AND operator is pretty strict. Use the AND operator whenever you need two conditions to pass before starting an action. For example, say you have a login form on your website. You might check to see that both the username and the password fields are filled out before submitting the form. If either field is empty, then don't submit the form. Other times, you'll want to perform an action if either of two possible conditions are true. For example, if it's hot or the indoor pool is open, then I'll go swimming. In this case, either condition can be true. It might be really cold outside, but the indoor pool is heated and warm, so I'll go swimming. On the other hand, the indoor pool may be closed, but it's hot, so I'll go swimming in the ocean. This type of test is called an OR operator. In other words, the whole condition is true if either condition 1 or condition 2 is true. The OR operator is represented by two pipe characters. On most keyboards, the pipe character is on the same key as the backslash. Hold down the Shift key to type it. Let's see how the OR operator works. Say you let someone agree to the terms and service of your website by typing either yes or just the letter Y. You can type either one or the other. Let's imagine that the visitor's response is stored in the variable called agree. We could then use the OR operator like this. Just like with the AND operator, there's really two separate conditions here. Does agree equal to yes? And does agree equal to Y? Each condition is tested separately and produces its own true or false values. Let's try this out. Imagine that the value in the agree variable is yes. The first test asks if yes is equal to yes. Well, yes it is, so that first condition is true. The second test asks if yes is equal to Y. Well, this isn't true at all. The OR operator steps in and asks if condition 1 is true or condition 2. In this case, yes, 1 is true, and that's enough. Let's continue with two more examples. Let's assume that the value in agree is the letter Y. The first condition is false. Y is not equal to yes. But the second condition is Y equal to Y is true. So the entire condition is true. Just the one test needs to pass. How about we set the value of agree to N? The first condition is false and the second condition is false. In this case, because neither condition is true, the whole condition becomes false. Keep in mind that you need to create complete conditions on either side of the OR operator. For example, you can't do something like this. It feels like that should be right. It reads like if agree is equal to yes or Y. However, the stuff that appears on either side of the OR operator has to be a complete condition. Y by itself isn't really a condition. You need to have full conditions on either side, like this. In these examples, I've been using just two conditions and a single logical operator. You can actually have more than one AND or operator. For example, you can test if condition 1 is true, and condition 2, and condition 3, and condition 4, and so on. There's no limit to the number of AND operators you can string together. Just remember that with the AND operator, every single condition must be true for the entire condition to evaluate to true. If just one of the conditions is false, then the entire condition is false. You can also string together multiple OR operators. In this case, only one of the conditions needs to be true for the entire larger conditional to evaluate to true. In this example, if any of these three variables contains an empty string, then the entire condition is true. Ready for a challenge? You've learned a lot about JavaScript so far: variables, strings, numbers, and conditional statements. In fact, you've learned enough to put together complete programs. For this challenge, I want you to write a simple quiz application. The application needs to do several things. First, it has to ask at least 5 questions. Second, keep track of the number of questions the user answered correctly. Third, provide a final message after the quiz letting the user know the number of questions he or she got right. And fourth, rank the player. If the player answered all 5 correctly, give that player the gold crown. 3 to 4 is a silver crown. 1 to 2 correct answers is a bronze crown. And 0 correct is no crown at all. In the next video, I'll show you how I would program this challenge. Good luck.
How'd you do in the challenge? Were you able to complete it? Let me show you how I did it. First, I start by creating a variable to hold the number of correct answers. I set this to 0 because at the start of the quiz, 0 questions have been answered. As somebody takes the quiz, I'll add 1 to this variable for each question answered correctly. At the end of the quiz, the total number of correct answers will be stored in this variable. Notice I also add a comment to explain what the code is for. I'll add another comment to introduce a new section to the program and begin by asking a question using a standard prompt method. I need to test to see if the response is correct. I'm using the toUpperCase method to convert the user's input to all uppercase letters. This lets the student get the answer correct whether she spells the answer with all lowercase, all uppercase, or any combination. If the person provides the correct answer, the plus equals operator adds 1 to the current value of the correct variable. Asking a question and testing the response is the heart of this program. I just need to add 4 more questions. The code is pretty much the same. I just need to create different variables to hold the different answers and ask different questions. Now I can output the results. I'll start by telling the player how many questions she got right. Then I'll provide a message based on the number of questions answered correctly. First, if they get all questions correct, they earn a gold crown. Now I'll run a second condition with an else-if clause. Remember from my instructions for this challenge that a player gets a silver crown for 3 or 4 correct answers. Notice here that I'm just checking to see if the value in the correct variable is greater than or equal to 3. You might say to yourself that the condition will also evaluate to true if the number of correct answers is 5. So will this message also be printed out if the player got 5 answers correct? No, and here's why. Remember that an if-else-if-else statement only ever leads to a single code block. Remember, even though there may be multiple doors or conditions, the program only ever goes through one of them. In this case, the first if statement at the top tests for 5. That means if the correct variable has the number 5, the program enters this code block, runs its code, which prints, "You earned a gold crown," and then exits. In other words, if the player answers 5 questions correctly, the program never gets to this else-if condition. Finally, we can test for the bronze crown and with a final else clause print out the "No crown for you" message. There are other ways you could have solved this problem, but this solution is simple and straightforward. You may notice that some parts of this code do the same thing over and over, like here, asking the questions. You'll see in the next stage that JavaScript functions provide a more efficient way to execute code that you want to repeat again and again. But for now, congratulations on reaching the end of another stage in your JavaScript programming journey. I'll see you in the next stage.